Let us start with the imaginary numbers. I am taking this number square root of -7. This is not a real number because the square root of a negative number is not a real number. Any number that is not real is called an imaginary number. So this is an imaginary number. Now I am taking this number square root of -10. This is an imaginary number. This is equal to square root of, I'm going to write -10 as -1 times 10. -1 times 10 is -10. This we can write as square root of -1 times square root of 10. I'm taking this square root of -1 as I. So this is equal to, this is I times square root of 10. So an imaginary number can be written as a real number times I. This I is equal to square root of -1. Now let us find what is the value of I squared. So the I squared is, this I is square root of -1 square. So that is equal to, so square root of -1 square is -1. So I squared is equal to -1. Here I have these imaginary numbers. I'm going to write these imaginary numbers in terms of I and simplify. First this one, this you can write as I times square root of 64. Put an I and remove the negative sign. This is equal to I square root of 64 is 8, equal to, first write this number, then I. Now this one, this is equal to I square root of 50. Put an I and remove the negative sign. This is equal to I. Now you can simplify this. This is a square root. These are the perfect squares. This 50 you can divide by 25. You get 2. So this 50 you can write as 25 times 2. Now you can factor out this 25. I square root of 25 is 5. Now you have square root of 2 equal to, first write this number, then this I, now the square root. Now this one, this is equal to, there is a minus sign outside the square root. Put that. Now you can write this as I times square root of 108. This is equal to negative I. This 108 you can divide by 36. You get 3. So this can be written as 36 times 3 equal to negative I. This 36 you can factor out. You get 6. Square root of 36 is 6. Now you have square root of 3 equal to minus 6. Then this I. Then this square root. Note that there should not be any perfect square inside the square root. You must factor out. Now we are going to multiply two imaginary numbers. This is equal to, first write in terms of I. So you can write this as I times square root of 7 times, this is I square root of 4 equal to, now multiply I and I, you get I squared, then square root of 7 times the square root of 4 is 2 equal to, this I squared is minus 1. So substitute negative 1 for I squared times square root of 7 times 2 equal to, now you multiply negative 1 and 2, you get negative 2, and here you have square root of 7. Now this one, this is equal to I square root of 16 times I square root of 49 equal to, multiply I and I, you get I squared, square root of 16 is 4 times square root of 49 is 7 equal to, I squared is negative 1 times 4 times 7 is 28 equal to, negative 1 times 28 is negative 28. Note that you cannot do this. That is, you put your square root and multiply this, negative 7 times negative 4 equal to, you are multiplying two negative numbers, you get positive, then 7 times 4 equal to, you can factor this 4 out, you get 2. Now you have square root of 7. So you are getting positive 2 square root of 7. This is not the correct answer. The correct answer is negative. So you don't do this. Don't multiply two negative numbers inside the square root. Now we are going to divide imaginary numbers. This is equal to, write this imaginary number in terms of I. This is I square root of 294 divided by, this is equal to I square root of 6. Now you can cancel this I and this I. Now equal to, you are dividing two square roots. You put one square root and divide 294 divided by 6 equal to square root 294 divided by 6 is 49 equal to square root of 49 is 7. Now this one, this is equal to, write this imaginary number in terms of I square root of 25 divided by, this is a real number, write this number equal to I. Now combine these two into one square root and divide 25 divided by 5 equal to I. 25 divided by 5 is 5. So you get square root of 5. This is the answer. Now you know what is an imaginary number. Now the question is, what is a complex number? I have this number 3i. This is an imaginary number. Now I am adding a number 2. This is a real number. This number is called a complex number. So a complex number is the sum of a real number and an imaginary number. This is another complex number. You have a real number and you are subtracting an imaginary number. This is another complex number. It's a real number. You are adding an imaginary number. Next, the standard form of a complex number. A plus bi. This is the standard form of a complex number. You have the real number and the imaginary number. This A is called the real part and this B is called the imaginary part. Examples: this is a complex number in standard form. You have the real part and the imaginary part. This is also in standard form. Real part, imaginary part. And here, this is the real part and this is the imaginary part. So this is in standard form. Next, we are going to add and subtract complex numbers. Now we are going to do this problem. Here you have two complex numbers. You need to add, and here you have two complex numbers. You need to subtract. And write your answer in standard form. First we do this. This is equal to add or subtract. First you need to remove the parentheses. So you have these parentheses. But before this parenthesis, there is nothing here. So you can just remove these parentheses. You get this. Here you have these parentheses. Before this, you have a plus sign. So you can just remove these two. You get this. Plus 7 minus 10i equal to, now you have negative 4, positive 7. You can combine these two. Negative 4 plus 7 is 3, positive 3. Now you have I here, I here. So you can combine this and this. 11i, positive 11i, negative 10i is positive 1i equal to 3 plus 1i is I. 1 times I is I. So plus I. This is the answer. This is in standard form. You have the real part and the imaginary part. Now this one, this is equal to, so here you have these parentheses. Before this, there is nothing, so you can just remove these parentheses. So write this 2 plus 9i. So here you have these parentheses. Before this, there is a minus sign. So when removing these parentheses, you need to change the sign. This becomes plus, this becomes minus. So plus 5 minus 6i equal to, you got 2 plus 5. You can combine these two numbers. 2 plus 5 is 7. Here you have I, 9i, negative 6i. So you can combine these two. Plus 9i minus 6i is plus 3i. This is in standard form. You have the real part and the imaginary part. So this is the answer. Now we do this problem. You need to multiply this 4i and this complex number and write your answer in standard form of complex number. This is equal to, you multiply this and this. First multiply the numbers 4 times 2, 8 times I. Now this and this. 4 times negative 12 is negative 48. Now multiply I and I squared equal to 8I minus 48. This I squared is equal to negative 1. So you need to substitute the negative 1 for I squared equal to 8I minus 48 times minus 1 is positive 48. Now you need to write this in standard form equal to, write the real number, real part, then this, the I imaginary part, plus 8I. Now we do this problem. You need to multiply this complex number and this complex number. This is equal to, first you multiply this and this. 1 times 96 is 96. Now this and this. 1 times 95 is 95 times I. Now this and this. 98 times 96 is positive 48 times I. Now this and this. Negative 8 times 95 is positive 40. I times I is I squared equal to 96. Now you can combine these two. There is I here, also here there is I. 95I plus 48I is plus 43I plus 40. This I squared is negative 1. So you need to substitute negative 1 for I squared. 40 times I squared is negative 1 equal to 96 plus 43I plus 40 times negative 1 is negative 40 equal to, now you can combine 96 and negative 40. 96 negative 40 is negative 46 plus 43I. This is the answer. This is in standard form. Now we are going to do this problem. Multiply 7 plus 4I squared. So there is a square here. Square means you need to multiply this 2 times. So this is equal to this 7 plus 4I times 7 plus 4I. Multiply this 2 times. This is equal to, now you multiply this and this. 7 times 7, 49. Now this and this. 7 times 4, positive 7, positive 4 is positive 28 times I. Now this and this. Positive 4 times positive 7 is positive 28 times I. Now this and this. Positive 4 times positive 4 is positive 16. I times I is I squared equal to 49. You have 28I, 28I. You can combine this and this. Plus 28I is plus 56I plus 16. This I squared is negative 1. So you need to substitute -1 for I squared. So 16 times -1 equal to 49 plus 56I plus 16 times -1 is negative. 16 times -1 is -16 equal to, now combine this and this. 49 minus 16 is 33 plus 56I. This is the answer. This complex number is in standard form. Next, complex conjugate. I have this complex number a plus bi. This is the real part, this is the imaginary part. Now change the sign of the imaginary part. Change the sign, you get a minus bi. This is called the complex conjugate of this complex number. Examples, this is a complex number 8 plus 12i. Change the sign of the imaginary part, you get 8 minus 12i. This is the complex conjugate of this complex number. This is another complex number 10 minus 7i. Change the sign of the imaginary part, you get 10 plus 7i. This is the complex conjugate of this complex number. Next, we are going to multiply a complex number and its conjugate. I am taking this complex number a plus bi. This is the complex conjugate of this complex number. Now let us multiply this and this. This is equal to, here you have a here, bi. Only difference is here plus, here minus. So this is same as a plus b times a minus b. This is equal to difference of squares. Difference of squares. So we can write this as a difference of squares equal to, so this a squared, that is this a squared, minus, for b we have bi. So bi squared equal to a squared minus this we can write as b squared times I squared equal to a squared minus b squared. This I squared is minus 1 equal to a squared minus b squared times minus 1 is positive b squared. So this times this, a complex number times its complex conjugate equal to this a squared plus this b squared. Now we are going to do this problem. You need to multiply these two complex numbers. So here you have 5 plus 11i and here 5 minus 11i. So only difference is here plus, here minus. So this is the complex conjugate of this complex number. So this is equal to, you can use this formula, a plus bi times a minus bi is equal to a squared plus b squared. So this is a, So a squared is this 5 squared plus this. This is b. b is 11. 11 squared equal to 5 squared is 25 plus 11 squared is 121 equal to 146. Now we are going to do this problem. You need to divide this by this complex number. To divide, so first write this equal to this divided by this. Now take the denominator, take this complex number and find the complex conjugate. You change the sign. 3 minus 4i. This is the complex conjugate of this complex number. Now you need to multiply and divide this. So multiply and divide. Put parenthesis equal to. Now you can simplify this by using this formula. So this 3 is A, this 4 is B. So A squared plus B squared, that is 3 squared plus this 4 squared. So here you need to multiply this and this. So multiply this and this. 25 times 3, 75 I. Now multiply this and this. 25 times 94 is 100. I times I is I squared equal to 3 squared is 9 plus 4 squared is 16. Here you have 75 I minus 100. This I squared is 91. So you need to substitute 91 for I squared equal to 75. So in the denominator, you have 9 plus 16, 25. Here 75i, negative 100 times minus 1 is positive 100 equal to. So now you need to write the answer in standard form. So you need to separate the imaginary part and the real part. So divide this by this plus this by this equal to. Now you can divide 75 by 25. You get 3i. Here 100 divided by 25 is 4. So equal to 3i plus 4 equal to, first write this 4, then this plus 3i. So this is in standard form. So this is the answer. Now we do this problem. You need to divide this complex number by this complex number. So this is equal to, first write this. Now take this complex number and find the complex conjugate. You change this sign. You get 7 plus 4i. Now you need to multiply and divide this. So multiply and divide. Put parenthesis equal to. Now this you can write by using this formula equal to a squared plus b squared. So this is a 7 squared plus this 4 is b 4 squared. You don't have to put any sign here. Now you need to multiply this and this. So first to multiply this and this. 5 times 7, 35. Now 5 times this. 5 times 4, positive 4 is positive 20 times I. Now multiply this and this. Positive 3, positive 7, positive 21. 3 times 7, 21 times I. Now this and this. Positive 3 times positive 4 is positive 12. I times I is I squared equal to 7 squared 49 plus 4 squared is 16. Now here 35, you can combine this and this. 20I, 21I. Both are positive. Add these two, you get 41I plus 12. This I squared, you need to put 91 equal to 35. Okay, so in the denominator, you add these two, you get 65. Here you have 35 plus 41I plus 12 times 91 is negative 12 equal to, now you can 65. Here you can add this and this. 35 minus 12 is 23 plus 41I equal to, now you take this and divide. Also this plus 41I, 41 divided by 65, put the I here. This is the answer. This is in standard form. Let us do another problem. Divide. You need to divide this complex number by this complex number. Equal to, write this. Now take this complex number and find the complex conjugate. You change this sign. 92 minus 9i. Now you need to multiply and divide this. Put parenthesis. Equal to. Now you can write this by using this formula. Equal to a squared plus b squared. This negative 2 is a. This 9 is b. Since we are taking square, you don't have to put the sign. Negative 2 square is same as 2 square. You get a positive number. So you can ignore the sign. Just to put the number 2. 2 squared plus is 9 squared. Now here you need to multiply this and this. First to multiply this and this. Negative 6 times negative 2, positive 12. Now this and this. Negative 6 times negative 9 is positive 54 times I. Now this and this. Negative 7 times negative 2, positive 14 times I. Now this and this. Negative 7 times negative 9. Negative 7 times negative 9 is positive 63. I times I is I squared equal to 2 squared is 4 plus 9 squared is 81. So here you have 12. You can combine this and this. 54I and 14I. Positive 54I plus 14I is 68I plus 63. This I squared is minus 1. So you need to put negative 1 for I squared equal to 4 plus 81 is 85. Here you have 12 plus 68i. 63 times 91 is negative 63 equal to, now you can, so in the denominator you have 85. So here you can combine this and this. 12 minus 63 is negative 51 plus 68i equal to, now put this and divide this by this, minus sign, plus divide this by this. Now you have I. So this is the answer. Now let us do this problem. You need to divide this by this. In the denominator, there is only one term. So there is an I. So this is positive. So equal to, you write this. So this is positive 2I. So you just multiply a negative I and divide negative I. So multiply and divide negative I. If there is a minus here, you need to multiply and divide a positive I. So this is positive. So just to multiply a negative I and divide the same. Equal to, now put parenthesis. So here equal to, now 2I times negative I is negative 2 I times I squared. Now you multiply this and this. So multiply this and this. 8 times negative I is negative 8I. Now multiply this and this. Negative 5 I times negative I is positive 5 I times I squared. Now equal to, so now you need to substitute negative 1 for I squared, or this I squared and this I squared, equal to negative 2 I squared is negative 1. Here negative 8 I plus 5 is I squared is negative 1 equal to negative 2 times negative 1 is positive 2. So you are getting a positive number in the denominator. Now here negative 8I, 5 times negative 1 is negative 5 equal to, now you take this and divide by 2. Also negative 5 minus this 5 divided by 2. This 8 you can divide by 2, you get 4. So equal to negative 4 minus 5 divided by 2. So there is an I here, minus 4I minus 5 divided by 2. So now you write this first, then the imaginary part, this, then this. So this is the answer in standard form. Now we are going to find what is the value of I cubed and I to the fourth power. You know I is equal to square root of negative 1 and I squared is negative 1. So what is I cubed? So I cubed can be written as I squared times I equal to, this I squared is negative 1 times I. That is negative 1 times I is negative I. So now what is I to the fourth power? I to the fourth power can be written as I squared times I squared equal to, so this is 1 this is negative 1, I squared times negative 1 equal to negative 1 times negative 1 is positive 1. Now let us find I to the 8th power. So I to the 8th power is, you can write as I to the 4th to the 2nd, because 4 times 2 is 8 equal to, this I to the 4th is 1, so 1 squared equal to 1. So also if you find I to the 12th, you get 1, and also I to the 16th is equal to 1. So if the exponent is a multiple of 4 or multiples of 4, you get 1. Now let us do this problem. You need to simplify this. You have an I, then there is a positive integer exponent. You need to find the values of this. So the answer should be one of these. You will get 1, -1, I, or negative I. Let us do this problem. First take this. To find the value of this, so you take this exponent, 77, and check whether you can divide this by 4. 77 you cannot divide by 4. Next, take 76. The 76 you can divide by 4. So now take this. This is equal to, you can write this as I to the 76 times I to the 1. So 76 plus 1 is 77. This I to the 76 is 1 because this 76 is a multiple of 4. Now you have I, that is 1 times I is I. Now this I to the 43, take this number and check whether you can divide by 4. This you cannot divide by 4. Now take 42. 42 you can divide by 4. 42 you cannot divide by 4. Now take 41. So reduce 1. 41 you cannot divide by 4. Now take 40. 40 you can divide by 4. So now I to the 43rd can be written as I to the 40 times I to the 3rd. 40 plus 3 is 43. So this is equal to 1 and times I to the 3rd. This I to the 3rd you can write as I squared times I. That is, I squared is negative 1 and times I. That is negative I. Now take this number 56 and check whether you can divide this by 4. So 56 you can divide by 4. So I to the 56 equal to 1. So now take this 98. Check whether you can divide by 4. You cannot divide by 4. Now take 97. This also you cannot divide by 4. Now take 96. This you can divide by 4. So I to the 98 you can write as I to the 96 times I to the 2nd, I squared. 96 plus 2 is 98. So this is 1 and I squared is negative 1. So I squared, this is I squared is negative 1. So 1 times negative 1 is negative 1. So this is the answer. So you are getting, so one of these as the answer. So 1 minus 1, I minus I.